Okay. So how to create the DFM report? So first of all, what is the DFM?
A design for manufacturing.
Design for manufacturing. So basically, if we are creating the DFM report, so basically DFM report is belong to the component, right?
Yes, sir.
है ना? Or DFM report can be belong to the mold design also.
Okay. Yeah, both.
both.
So one is for component, one is for mold.
Mold design. So basically, we are analyzing, or we are you can say that we are checking the
Understanding
component.
the component.
We are checking the component that that component is feasible for the molding or not. So basically, for blow molding process, there is a few points only. But if I'm talking about the DFM full DFM report, so basically if we study about the injection molded component, so basically you will get the lots of point there. Right.
Okay.
See, so basically right now we are we have to study about the DFM for the blow molded component, right?
Yes.
So first of all, we should have knowledge about the material type. For example, we are creating the DFM for this component, so we should have knowledge about the what is the material will be used for this component, right?
Okay.
Whether it can be P8 material, whether it can be HDPE, PP, right? So we have to confirm that material from the customer, which is very important, right? So for just for an example, we are using PET material, है ना? Part size, weight and the volume should be confirmed. Okay, so just for example, we are designing this component, so we have to give a small report to the customer that what is the capacity or the volume of the component, and what is the thickness, part thickness, wall thickness, we can say that, है ना? Part size, which is the length, width, or any type of basic dimensions, right? है ना? What is the weight?
Weight of the component.
Weight of the component, which will be in mass depending upon the density. Okay, है ना?
Okay.
Just for example, they are using paired PP material. So what is the density for the PP?
0.9 something.
Right. So apply this density to this component, and you will get the mass, which will be in gram, right?
So component, the design in the SolidWorks, let's say, if it is designed this component, then I need to multiply this weight into
Volume.
PP density to get the volume, proper volume.
Not the inner volume, okay? Not the inner volume, only
Yes,
component
sir.
volume.
Only the component.
Okay. And the functional and the aesthetic requirement. For example, for this component, what is the functional dimension here? Tell me.
Functional dimension.
There will be a cap here, right?
Okay.
Okay. So if this cap and this thread, है ना? So basically internal thread of this cap and the external thread of this
External thread
bottle
of the
should be met to each other in a proper way, right? So it should be functional,
Okay.
right? It will provide a function, right?
Yes, sir.
Okay, so it has a application, so it will be tight, so it will be closed in a proper way, right? So basically, if I'm dealing with the functional component, or what is the requirement of this component, so in this component you can see that only this is the main portion here, right? Which is the neck.
Okay.
Okay, so maybe it is possible that if I am designing this complete component, if I have, so basically here I have a open tolerance, right? But here for the neck portion I have to provide the accuracy.
Okay. Precision.
Right? Okay, here I can, so I can adjust the length. Okay, so maybe if for example like length has is 150 mm, so instead of the 150, maybe I can provide the 151. So there is no problem right there, right? But if I am providing the wrong dimension, or if I am getting the wrong dimension,
Then the alignment of the.
so that will be the big problem there. Understood? So this is where this dimension is very important. So basically this will be come under the critical dimension.
Okay.
Understood? This is very important. Okay, understood?
Yes, sir.
Okay. See, then analyze the mold and the process feasibility. So basically we are analyzing the component for the molding feasibility.
Okay.
Okay, here you can see that we are trying to find out the parting line. Parting line. So here you can see that what is this?
It's a parting line
Parting
between
line.
left side and right
So
side.
your parting line will be generated here. Just for an example, if we are dealing with the Parison,
Okay.
है ना? So basically, if we are making by the extrusion process, है ना? So basically, parting line will be here. Now, if for example, if we are dealing with the
Okay.
preform, so basically parting line will be here in same condition, right or wrong?
Okay. Yes, sir.
Understood? मतलब you can say that preform
But-
and the in both condition. Okay, but for
if you can,
हाँ,
if you consider complex products, then the parting line will be different, right?
different. It can be like this. It can be like this, and this, or in other axis.
So that means we need to understand the
Draft analysis.
component.
Draft analysis and the parting line.
Uh-huh.
है ना, which is very important. Draft angle and the parting line. Depending upon that, we have to select our parting line, right? Then we can create the core and the cavity region. See
Yeah.
here.
So that's the thing. That's the main important task, right?
Yes, this is the very important for any type of molding process. For the
Yeah, but
easy mold
if we
release,
create a wrong parting line, then it will be problem.
it will be
Either,
problem. Yeah, it mold will produce the wrong component.
yes, sir.
Right. So here you can see that draft is very important. This will be the draw direction, right? Draw direction means ejection direction, right? Ejection of the component, and wall thickness should be uniform. Just for an example, I have designed this component. Okay, I have designed this component. So basically here you can see that wall thickness is the uniform. Okay, and it should be uniform. But during the manufacturing by the blow molding process, so there is no possibility for uniform wall thickness, right?
Okay.
So right now this is the CAD model, as I told you, है ना?
Yes, sir.
Okay. Now here you can see that, but in our CAD design, it should be uniform, है ना? Here you can see that this is the 1 mm wall thickness here.
Okay.
See, maximum portion is the yellow portion. It means it is the uniform.
Okay.
Understood? And
Okay, sir.
understood? Okay.
Yes, yes, sir.
Okay. So basically, if I am asking to you this component or this bottle component, which method should be adopted with molding process? We should be adopt.
If it is having a high length, then we can consider directly stretch blow molding.
Okay. But if we need this accuracy, then
Then injection molding.
yeah, injection blow molding we have to use. So injection stretch blow molding we have to use, right?
Okay.
So basic stretch molding we can use here. Okay, because
of the
we
threading.
need this accuracy. This is very important.
Okay. Okay, sir.
Okay, so by
But
the
if
injection,
if there are if the same neck portion, if the precision we are requiring like bellows in the middle of the component, then we can't consider the same process, right?
yes.
If the critical area, if it is in any other section rather than the top or bottom in the middle, then we can't consider this kind of design molding process.
No, we cannot consider then.
Then how to analyze that kind of designs?
You are asking that, for example, this neck portion is here also, just for example, right?
Okay.
है ना? And this neck portion is here and here also. You are asking that?
Yes, sir.
Okay. So basically we have to use the another method, which is the
Okay.
Parison method. है ना?
Yeah.
We have to use.
So that means completely blow molding.
It will be blow molding. It will be blow molding, but we have to use that. But depending upon the requirement, as I told you. Okay.
Yeah.
तो
Not for the bottle, anything it may be.
Yeah. So basically, then for example, like its application will be different, right? And you can say that material will be different again. Now, if I'm going for the this type of bottle, and if I'm going with the preform, right? Preform.
Okay.
Though it means it is the higher possibility that it will be the PET material, right?
Yes, sir.
Understood? Then
Yes,
now
sir.
if you are going with the Parison method, so maybe material will be changed, application will be changed, or other thing will be changed, right? Right?
Yes, sir.
And the accuracy will be also changed. So that is the factors that will affect.
Yeah.
Understood? है ना?
Okay, sir.
Now analyzing the mold and the process feasibility, तो proper venting and the cooling placement is very important. So we have to consider that also, right?
Okay, sir.
Okay. Now see, perform manufacturability check, right?
Okay.
So can the part be blow molded with the minimum defect? Okay, so we have to check by the analysis software. So
Okay.
right now I don't have analysis software for the blow molding process. So I am trying to download Moldex. Moldex.
Mold?
Moldex.
Moldex.
Moldex 3D. So this is the name. I'm trying to install that software for showing you how to perform the analysis portion for the
Okay.
DF1, making the DFM report, right? So which is very important for the prediction purpose, that it will be what is the air pressure required for the component, and depending upon the wall thickness what material we required, right? And or what will be the weight of the component. So depending upon that, okay, so
Okay.
I will just install that software. Okay,
Okay, sir.
है ना? Is the Parison or the preform shape optimized or not? है ना? Is the blow pressure or the stretch ratio within the limits or not, right? So we have to take the we have to give
Take these things
yes,
into consideration.
yes. So that this all the answer will provide that software, right? So that software will be provide that answers. So here you can say suggest design improvement. Okay. So here you can say that reduce the sharp corner first of all. This is the our concern, which is the designer, right? है ना? So any type
What's the
of
problem if there is a sharp corner?
just for an example, like you have a component, okay, and this is the sharp corner. Just for an example, this is the sharp corner here. Yes. So at the sharp corner, material can be cut easily.
Because of the mold.
Because if I'm talking about the mold material, so it will be P20 or the steel, right or wrong?
Yes, sir.
So if you provide the sharp corner there, and when the material will be stuck here, or when the material will be, है ना? So basically it will be cut from there,
Okay.
or it will provide the minimum wall thickness there. So once you provide the radius, so basically it will provide the uniform wall thickness to the component, and uniform distribution, you can say that, right?
Okay, sir.
So that's why we should reduce the sharp corner or the unnecessary undercut if the component have, right?
So this, can you, I mean, I understood sharp corners. Can you explain me undercuts?
Undercuts.
Concept.
Just for an
I
example.
don't know. I don't know what is undercut,
Okay.
and I don't know how it is formed. I don't know how to rectify that.
Okay. Just for an example, for the blow molded component, okay? Like for example, like this is the bottle, okay? And this component has feature like this. Just for an example, right? Right now this feature is 90, okay? This
Okay.
is 90 degree. This is 90 degree. Just I am zooming this portion. So it will be like this. It will be like this. So this is the 90. Understood?
Okay.
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 And like a cola bottle.
Okay.
Like a cola bottle, see, this is nothing but this is the. So here, for example, if I am watching this component from this direction, understood?
From the side view.
Yeah, from the side view. So which you can say that which is not visible for me, like
The other side.
right? And this is the parting line, and
the down part.
the ground. So you can say that this is nothing but this will be the undercut, right or wrong?
Okay.
This is the undercut, okay? And just for an example, this is 90 degree, right? So here you can say that you will find the only single line there, right?
Okay.
You will find a single line. You will get this depth or not?
Which depth?
Depth means this depth.
Ah, yeah, yeah.
Yeah, you will
So
get
from,
this depth. No,
okay.
you cannot see the depth there from here, right?
Yes, sir.
You will get the single line there, right? So
Yes.
basically, but if I will provide the draft to this. Just for an example, I will provide the draft to this. Now, what you will
Okay.
get there?
So I can see the cross inclined line.
Yeah, you will see like this, right or wrong? Understood or not?
No, the draft one I didn't understand.
Just for an example, like this is the plane. This is the plane. If you are watching this plane from this direction, so you will get like this,
Ah, okay, okay, sir.
right?
Like a
Or
block.
for example, this plane is nothing but 90 degree. At 90 degree, so what you will get? You will get the
Line.
single line,
Yes,
right?
sir.
So
Okay,
that's
understood.
why this 90 degree can be a undercut also, right? Why?
Yes.
Because for example, like this 90
There
degree,
is no
just for
visibility.
this for example, like this is the mold you have, है ना? And you
Yes.
are trying to pull this mold at this direction, right?
Yes.
So basically,
Yes.
it will create the friction here. It will create the friction
So
during
the
the
plastic creates a friction.
plastic and the mold also. It will
Okay.
during the deattachment, it will create the friction. So it should not be create the friction there. That's why we
Yes,
have
it
to
should
provide
be
the
free.
draft. Yes, we have to provide the draft, and this is nothing but this is the unnecessary undercut. If
Okay.
there is no requirement for this, so we can provide the flat area.
Yes.
We can provide the flat area. So there is no need of that, right? Understood?
Yes, sir.
है ना? So basically, if I am dealing with the molded component, okay, so that's why I show you this type of undercut. Just for an example, like I have one more component. 1 minute.
Let me send you my component, then you can try to explain me from that.
Do you
I will
have
send you a photo.
have you sent
One-
any picture?
I'm sending you now.
Just send me.
1 second. Desktop. So I sent you a photo. Once check that, sir.
Okay. Here you can see that this is the undercut.
How and why?
See, understood?
How it is an undercut and why it is an undercut?
Okay.
Can you explain?
Just for an
this?
example, if I'm 1 minute, if I'm consider the draft analysis for this component, okay.
Okay.
So here you can see that this will be the parting line, right?
Okay.
है ना? This will be the
Okay.
parting line, okay. This is
Okay.
the cavity region,
Okay.
okay, and this inner portion which is not visible, it will be the
That
core.
is also cavity.
It will be the core.
But it is a blow molding, right? So we need to consider it as a
Acha,
cavity.
it is the blow molded component.
Yes, sir.
Okay, it is the blow. So there is no here.
It's
One
a
minute.
tank.
So it's a tank. Okay. I thought this is the injection molded component because
No. It's a
okay.
tank.
It's a tank. Okay. So here there is no undercut here. There is no undercut here.
Then
So parting line will be here. Parting line will be like this.
okay.
Like this. This will be the parting line. Okay. This will be the
Okay.
parting line like this. So here there is no undercut here. Basically this
But what
this
about
feature
the neck region?
neck region. This is the neck here, right?
Yes.
No, this is not undercut.
It's not an undercut.
It is not undercut. So there is no undercut into this component.